So if you want your exam, you can come down to my office after class, and I'll give it to you. All right? So been thinking about what we want to do today. We've kind of gotten to a point where we are kind of free to explore several different topics. As far as the core material of pre-calculus, like we've covered what we need to cover in terms of understanding the unit circle, the trigonometric functions, the inverse functions, the graphs, identities, equations, general solutions, all that stuff, law of cosines, law of sines, all that, the core of it, we've got, all right, we've discussed. So there's some stuff that we were actually supposed to start the semester with that I didn't do. And I think I told you back then I do it a little different. I wanted to start with the pre-cal and then get to this stuff now. So we're going to start with kind of a fresh blank slate today. This is going to be a lot of algebra. And we're going to be doing what's called partial fractions. So you will not see any trig stuff at all in this, all right? Partial fractions. Question? What?
I wanted to ask about the homework. Should we do the dot product from the last section?
I am going to cover dot product.
Okay.
But I wanted to start, we started covering dot product. My idea is next week we'll do dot product and polar coordinates. I want to spend this week just doing partial fractions. So hang tight on the homework for dot product. All right, so partial fractions. We only have 4 class meetings and then a final. All right, we have today, we have Thursday, next Tuesday, next Thursday, and then our final is the following week. All right, partial fractions. So let's see if I can't motivate this idea with an example. Let's say we have 2 over x plus 4, and we want to add that to 3 over x minus 7. So this is a college algebra thing. So we want to add these 2 fractions together. To do that, we need a common denominator, right? So what we would do is, and notice this is not an equation right now, so I can't like multiply both sides by anything. This is just an expression. So I will introduce a 1 next to each of these, like a 1 time, this times 1, this times 1, but what I choose for the 1 is going to be something that will give me the same denominator. So what do I need to multiply that first fraction by? The one, x minus 7 on the top and bottom, right? So I just insert here x minus 7 on the top, x minus 7 on the bottom. Let me go ahead and throw those in parentheses. Anywhere where I'm going to have to do some sort of distribution, I'm going to put parentheses. And over here on this one, I'm going to introduce what? X plus 4 over x plus 4. So when I do this, even though I'm going to change the look of the fraction, it will be equivalent because this is a 1 and that's a 1, right? So this is a legal move that I'm doing. And now, do not cancel these out, okay? If you cancel them out, you're going to be back to where you started, all right? Instead, what we're going to do is distribute the 2 through, we'll distribute the 3 through, and since they have the same denominator, I can put them together into one fraction. So what will my numerator be if I distribute the 2 through there?
2x minus 14.
2x minus 14, and then I'm going to combine that with, so plus the 3x plus 12. And then from here, I can put this all over the common denominator, which I could multiply out, right? I could actually FOIL that out, but I'm not going to yet. I just want to leave it like that. Let's clean up the numerator. That's what? 5x minus 2 over x minus 7 times x plus 4. And now I'll multiply out the denominator and get to what, x squared, then you combine and minus 3x minus 28. Yes? Now, in math 1414, college algebra, you should have done something like this. This is working with what are called rational expressions. So it turns out that in Calculus 2, we need to be able to do something like this, but not, let me back up. Let me erase this real quick. Let me rewrite the original problem up here. 2 over x plus 4 plus 3 over x minus 7. So, like I was saying, in Calculus 2, you must be able to do something where you don't go from here to here. You actually have to go from here back to this. Okay? And that's called partial fraction decomposition. And it winds up helping us do difficult problems. So we have a hard problem, and if we can do this decomposition into this, then it makes those problems relatively easy. But this is a skill. It's not an easy thing to do in general. So let's just try and appreciate what it would take to go backwards from this. Because the forward, like from left to right, this all makes sense? Okay. So going backwards, we could go from here to here, couldn't we? All right. Now, from here to here is the big trouble step. Because how do I know that 5x came from 2x and 3x, right? It could have been 4x and 1x. It could have been 8x minus 3x, right? How do I know that that 5x came from 2x and 3x? And then how do I know that minus 2 came from minus 14 and plus 12? Like, how would I have any idea?
Because the factor comes from two proportions.
Well, we know it comes from two things, right? But how would I know that it's a 2 and a 3 as opposed to a 1 and a 4? Right? Like, there's an infinite number of ways I could get 5x.
Yeah.
Right? I could do 13x's, take away 8x's, and I had to have 5x's. So getting from here to here is not something that's straightforward. Do you all see that? And then, you know, once we got it to here, yes, we could come back. But it's this step right here, from here to here. So it turns out that there's an entire process that we have to learn to do this. And it's not super straightforward, but it's not that bad. All right? So let's keep our eye on the prize. We are going to start our problem by, I'm going to present this as its own problem. And remember that the answer we want to get to is we want to get to this, okay? That's where we started. So as your first example, we are going to take 5x minus 2 over x squared minus 3x plus minus 28. And let me use this, well, I don't need the book. Use partial fractions to decompose this expression. All right. I think that marker's had it. Yeah. All right. So here's what we have to do. First step, and I can give you a set of steps, all right? I can actually give you a process, but it's rare. If you look at it, it just looks like overwhelming because it's just so much stuff. So on these first few examples, I'm just going to verbally kind of guide you through it, and then later on we'll try and put some structure to the process. All right? So I know that the denominator here, when I look at this, I know I can factor the denominator, right? It's a quadratic. Well, I think I can, right? I mean, we know we can, but generally I may or may not be able to factor this, right? And I also notice that the degree of the numerator is smaller than the degree of the denominator. The degree is the highest power of x. So this is a degree 1. This is degree 2. So my numerator is smaller than denominator, degree-wise, right?
It has to be.
What happens if it's not? We'll have another road we have to go down, okay? But right now I'm recognizing I've got lower degree on top than I have on the bottom, and that the bottom does factor. So let me start by doing the factoring. So 5x minus 2 over And then you've got to know how to factor. You probably have been told that for quite some time now, right? So you break that down like that, right? And now comes another important juncture where we have to look at the denominator and we have to identify what types of factors these are. So this right here is a linear factor. And what do I mean by linear factor? Well, it's in parentheses, right? And it's being multiplied by something, so that makes it a factor. Am I recording? Is my audio on? Yes, I'm recording. Okay. This makes it a factor. It's a linear because the highest power on x is 1. So like if you just like erased everything else, that would be a linear expression, wouldn't it? Okay. So I have a linear factor here. This one is also a linear factor. And these two linear factors are distinct. What do you think I mean by that? They're distinct. That's the language that the book is going to use. Well, when you say that you are distinct from something, it means like you're different, all right? That you can distinguish between the two. These two factors are not the same factors, right? If this was x minus 7 times x minus 7, then I'd have two linear factors, right? But they would be the same. We call that a repeated linear factor. These are distinct linear factors. Got me? Okay. So we've got two distinct linear factors underneath this expression. Follow that language? Two distinct linear factors. If we ever see a situation like this, then what we do is we say that this must equal, and I'm going, because I have two distinct linear factors, I'm going to say that this must equal two fractions added together. The two coming from two distinct linear factors. If it were three distinct linear factors, I would have three fractions over here. And we know that, right? From this, we know we need to get back to this. The two distinct linear factors is what's going to guide us to that, all right? Now, below each of those fractions, I'm going to place each of the distinct linear factors. The only thing we don't know is what's the numerator. What's this and what's this? Now we do know it's going to turn out to be 2 and 3, right? But if we didn't know that, it's going to be some number here and some number here that we don't know. So we're going to assign variables to them, a and b. If there were three distinct linear factors, I would do a over the first one, b over the second one, c over the next one. And if there were four, a, b, c, d, right? Okay, y'all good? All right, so at this point, we are going to try to figure out what a and b are. All right, we're going to try and resolve what the a and the b are in the problem. So I have an equation, don't I? This is an equation now? And when I have an equation, I am always allowed to multiply both sides of the equation by the same thing. So I'm going to choose at this point to clear the fractions out completely. So I'm going to find the LCD, the least common denominator, and multiply the left side and the right side by the least common denominator. Which in this case, what would the least common denominator be?
X minus 7.
X minus 7, x plus 4. Those two factors. So let's go ahead and do that. Let's multiply the left side by x minus 7 times x plus 4. And remember, that's really like over 1. You don't have to put that, but that's what it is, right? Yes, yes? Okay, and on the right side, I multiply the same thing. Now, be careful here because this multiplies times the entire right side. You can do brackets or parentheses here. This thing is going to have to go through and multiply both of those. Now, what happens on the left-hand side? What happens when I introduce this?
X minus 7 cancels out, and then you're going to have a times
Okay, but what's on the left side? What's on this side after I cancel?
A times x plus 4.
This.
Oh,
5x minus 2 is still here, right?
Yeah.
Okay, so in my next line, the left side of the equation is still 5x minus 2. Equals, all right, equals, now let's distribute that x minus 7 plus 4 through. And I'll just kind of squeeze it in here on this first example. X minus 7, x plus 4 goes here, and then x minus 7, x plus 4 goes here, right? And then, like, I've passed it through, so I'm not, this is gone, right? So there and there. Now, what happens on that fraction that has the a in it?
it's going to lose the x minus 7.
The x minus 7 is going to vanish, right? Because you're going to go cancel them. You'll still have the a, and you'll still have x plus 4 in parentheses. So I'm going to write that. A, and then x plus 4 in parentheses. And then I have plus, and then over here we lose the x plus 4 is gone this time. And we're left with b times the x minus 7. Okay, there we go. Now, the problem that we have right now, the problem, the issue, okay, the trouble, is that we're trying to figure out what a and b are. We only have one equation, and we have actually 3 letters in this equation. So how could you ever figure out what a and b are if you don't know what x is, you don't know what a is, you don't know b? You know what I mean? 3 unknowns, 1 equation. It seems like we couldn't do this. But here's what we can do. We have 2 options. Okay, at this point, option 1, we'll call it option A. How about that? Option A, and this is going to be the shortcut. I'll just call it the short method. And then we have option B, which is the longer method. Now, let me tell you why you might want to use one over the other. Here's the thing. The short method is short, quick, and gets you there. But it doesn't always work. So that's the drawback. The long method is mechanically more work, but will work for any situation you run into. It's going to get you there. All right? So I always prefer to start with the short way and see if it works. And I'm going to show you both methods. All right. So the short method, here's what we do. We are going to look at the equation, and we are going to kind of play God for a second. We get to actually control what's happening in this little world. And what we're going to do is we're going to choose, however we want, we're going to choose a value of x. And we're just going to say, let x be something. Okay? Now, if I want to know what a is, I would love to just kill this completely off. So how could I kill this off if I can control x? Let x be 7. What would happen? If x is 7, 7 minus 7 is 0, that's going to kill this off completely. I won't have a b anymore, will I? So let me play that game. I start off by saying let, this is the God complex. You know what I'm talking about? Like I get to be in control here. Let x be 7. Okay. If x is 7, rewrite the equation. What does this equation become if x is 7? So 5 times 7, 35 minus 2, 33, equals, and every x gets replaced with 7. Okay, so 7 plus 4, 11 times a, right? That's 11a. And what about this one? Plus, we just said that was 0. So I'm just going to write it to remind you that, I mean, this thing does go away. And look at that little equation there. 33 is 11a. Divide both sides by 11, you get a is 3. We have a. Well, you have to go back and look at the way we wrote it. Okay, because the way we wrote it, this should be right. You can flip the order. But you can't mix up these numbers. They have to be over the right thing. We'll get back to it when we look at the final answer. Okay, well, I was able to recover what a is. How would you get b? You get to play God again. I hope that's not offending anyone. Can I use that word without offending anyone?
Tell it.
Should I say deity,
He's
or
gonna do something to you for
is it
you.
general enough if I say deity?
Little g God is fine.
Little g, okay, that's what I'm referring to then. Little g God. No,
DOG.
I'm sorry, I'm delirious up here. What are we going to do to kill off? What are we going to kill off?
Let's kill off the 8
How do we kill off the a?
with a 4.
Negative 4. X is negative 4. So we're going to let x be negative 4. All right. And plug in. So be careful here. 5 times negative 4, negative 20 minus 2. So negative 22 on the left equals negative 4 here is going to kill it off. And when you put negative 4 into here, negative 11, right, times b. So negative 11b. And if I divide both sides by negative 11, I get b is 2. Bam. We're there, okay? That was pretty, I mean, now that you see it, you could probably move through that pretty quick, that little short method. Now let me show you the long method, which again, you're going to sit there and say, well, why not we just do the short method? It doesn't always work. Huh? Okay, the long method. So here's the long method. This is a little weird, but just watch what I'm doing, okay? And then let's just see how this goes into your brain. Okay, what did I do there?
You distributed the.
Yeah, I just distributed. I distributed the A through here and the B through here. So we all good with that? Okay, now what I'm going to do is collect like terms. So I'm going to write 5x minus 2 equals ax plus bx plus 4a minus 7b. I'm just moving things around algebraically, right? Collecting like terms. Now, I'd like to put them together. So like, take a look at this ax plus bx. You could write that as x times a plus b, right? Like you could factor out an x from both of those. And this is multiplication, so I could write it that way, or if I chose to, I could write it that way. It's the same expression, right? X times this is the same as this times x. I'm going to choose to write it this way, and you'll see why in a second. And then over here, you see I have these two. I don't have anything in common over here, do I? But I am going to put them in parentheses for just to try and help illustrate something. I know that when I started this problem, I was looking for a and b, right? And a and b should be numbers, right? So this is saying that 5x minus 2 must equal some number in front of x plus some number, right? Right? 4a minus 7b is a number, and a plus b is a number. What are those numbers? It has to equal the left side. What's the number in front of x here? 5. That means that this 5 has to match this. Do you see that? And the minus 2 has to match with this. For those two to be equal, the coefficient, the number, in front of x on the left side must be equal to the coefficient, the number, in front of x on the right side. The constant by itself needs to be equal to the constant by itself in order to maintain equality of this equation, right? Any questions there? We're not done, but do y'all see that?
So now we're going to set them equal to.
We are now going to write down those two equivalencies together. So one condition I have is that a plus b must be equal to what? 5. Not x though, just the 5. So I have a plus b must equal 5. And the other thing I have is what?
Negative 2 equals 4a minus 7b.
Yes, and I'm going to write it this way. 4a minus 7b must be equal to negative 2, right? And this, from 1414, is called a system of linear equations. And that's why in college algebra you learn how to solve systems of linear equations. You need to be able to figure out what A and B are. If you're given two equations and two unknowns, you solve it. Do you remember the two methods to solve this? Substitution or elimination. It's your choice. Does this all kind of ring a bell or no?
Yeah.
A little bit?
This is the prior chapter in this section.
What, systems of equations? Yeah. Which we don't cover in here. Yeah, we don't cover it in here. So I'm going to choose to do this by elimination. That's the way I'm going to do this problem. That means I'm going to try and kill off either the A or the B. And I get to play however I want to play with this. So I see I can do it either way. If I want to kill off the A's, I need to make that a negative 4A. That way when I add down, they go away. I could also try and make that a 7B to make it add down. So what do you want me to do? Kill the A's or the B's? I don't care. A's? Okay, so let me go with A. That means I need to multiply this top equation by what? Negative 4. So I'm going to put negative 4 here. And I'm going to multiply that through. Remember that negative 4 has to go through the entire equation. And I'm going to rewrite the system now. The new system will become negative 4A minus 4B equals negative 20. And then the second equation does not get changed.
Where did you get negative 4 from?
I'm thinking about what it would take to make 4A go away. I would need negative 4A here. So I multiply by negative 4 so I get the negative 4A to happen. See how they're opposites now?
Yes.
Now with elimination, if I add these two equations down, so I add, I come up with a new equation. So what do I get if I add those? So this adds to be nothing. Then I get negative 11b equals negative 22. And now if I divide both sides by negative 11, I get b is equal to 2. Okay, when you're doing elimination, once you get one of the variables, what can you do? Like once I have this, what can I do now?
Plug it in.
Plug it in where?
In the original.
Any of these equations, okay? Any of them you want. So I always recommend go back to like the cleanest one that you have, which is probably this one, a plus b is 5. Right? Do you agree that's probably the cleanest one I have? So I'm going to just rewrite that equation. This, back in the elimination, this is called the back substitution step. We're doing back substitution now. So I'm going to take a plus b must equal 5, and I'm going to replace b with what? The solution 2, and now I have an equation for a, and I just subtract 2 on both sides, and I'm done. Longer? Yes, longer method? Definitely. All right, so let's go back and recap the answer. I said that the original problem was equal to a over something plus b over something. I forgot the factors I wrote. It's important that I put the right factor in the right place. So which one did I put first? I did x minus 7 here, and then x plus 4. That's what I had done. And we now know what a was. A was 3, so our answer is 3 over x minus 7 plus b, which we found was 2, over x plus 4. Bam. There we go. And that only took, what, 20 minutes?
Final answer?
Final answer, 30 minutes. Okay? Questions? I think another is in order. Like I said, this becomes a small step of a bigger problem in Cal 2. You start with this, and then you break it down, and once you break it down, then you continue doing the calculus. All right. My gosh, what was I thinking today?
You weren't.
I wasn't, yeah. I brought the wrong book.
Do you want to use this one? You need to.
I have some problems that I give to my Cal 2 students, so I'm just going to use those. Okay, how about this one? X squared plus 2x plus 1 over 2x cubed plus 3x squared minus 2x. There we go. We're jumping into the fire now, okay? Okay, so we're going to try and factor, but let's do that quick check. Is the degree up here smaller than the degree down here? It is, right? So we're going to go ahead and proceed now with some factoring of the bottom. So let's go ahead and rewrite. And I am not going to factor the numerator. Even if it factors, I'm not going to factor it. Only the denominator. Okay, how can I factor the bottom? You said x comes out, and then I'm left with 2x squared plus 3x minus 2. Y'all agree with that? Okay. Now you have a quadratic there, don't you? Does this factor?
I have to do the AC method.
So you might have to do some sort of method, right? To get that to factor. And I'm just here to tell you, like, you've got to be able to factor that. I mean, whether it takes you a few minutes on the side, but you should be able to get something here. Let's see. 2x, x2 plus minus 1. Does that work? Let's see. Does this work? 2x squared plus 4x. Take away an x, that's 3x, and then negative 2. So that is the correct factorization of that. What do you see in the denominator there? Let's see who's going to use the proper language. 3 distinct linear factors, right? They're all linear. That's a factor, okay? X by itself is a factor. It's x minus 0 in parentheses, but you don't write the minus 0. So there's a distinct linear factor. There's one, there's one. So 3. So that means that I know that this should break down to be 3 fractions. What's the denominator of the first one? X, second one. 2x minus 1, third one. X plus 2. And then we have on top, A, B, C. A, B, C. All right. Let's see if we can't move through this a little faster than we did that first one. This is the equation that I'm going to work with the rest of the way. Okay? I'm working with this. So what should I do now?
Get rid of the A's.
Get rid of something. Not
Get rid of something, right?
multiply both sides by
Oh, that's right.
the common denominator, the LCD, which is?
X times 2x minus
It's all 3 distinct linear factors, isn't it? So when I come in, see, I don't want to push too hard. If you don't see this, then please let me know and I'll write it down. But if I multiply this left side by this, what's left? Just the numerator, right? Won't it always be that way
Yes.
when you clear the fractions? If I multiply the left side by this, it's going to cancel, and all I'm left with is this. So really, at this point, you just write down the left side's numerator, which is x squared. I'll get rid of this. So that becomes x squared plus 2x plus 1 equals, now, I will write down, when we put the LCD on this side, it goes to every one of these. X, 2x minus 1, x plus 2, x, 2x minus 1, x plus 2, x, 2x minus 1, x plus 2, and just because I don't want to be super lazy, x, 2x minus 1, x plus 2. That was on this side, right? And they canceled completely. On the right side, it goes to each one. And really what happens is you get a lot of things that cancel out here, right? So you've got, like, the x's go away here. Here, the 2x minus 1s go away. And then here, the x plus 2s go away. Yeah? Okay. So my left side is this. My right side is equals a times those two things, right? I'm going to write that down. A times 2x minus 1, x plus 2, plus, what's b times? X, and then x plus 2. And then finally, I have to erase c plus c, and then x times 2x minus 1. There it is. We good? Let's try the short method first. Short method, which was option 1, or option A, whatever. I'll call it the short method. The short method, let's see if we can't figure out what A is. To figure out what A is, I need to be able to kill off the B term and the C term simultaneously. And you get to be lowercase god. So let x be what? 0. See, if x is 0, you're going to get a 0 here. It's going to kill that off. 0 here is going to kill that off. But notice 0 here and 0 here don't kill this off, right? 0 here would give me what? -1. 0 here would give me 2. That's not going to be a 0. But because these two terms have the x factor in them, if I let x be 0, I'll kill those two off. Clear?
Yes.
All right. Let x be 0. And fire away. What does this become? You have to write the whole equation. 1, right? Because 0, 0, 1. So 1 equals, and then a times -1 times 2, right?
Yeah.
Which is really 1 equals -2a. And if I divide both sides by -2, I get a is -1/2. Okay? Questions? Yes?
How do you know whenever short doesn't work?
Let's get to one where it won't, and then I think you'll see why it wouldn't. Yeah, the question is, how do we know short's not going to work? Until I show you one it doesn't work with, it's going to be hard for you to identify it. But what's going to happen is that when we're trying to kill off stuff, it's not possible. It's like if we try and kill these two off, we wind up having to kill them all. And so if you can't isolate one like we just did, then the method fails. All right, let's go after B. Can we get B? Can we isolate this term and wipe these two out? Well, do these two terms have a common factor that's not in this one? What's the common factor? 2x minus 1. If you can pick out an x right now that's going to make this 0, then you'll be able to kill this off, won't you? And you'll be able to kill this off at the same time. So what x would I have to plug in right here and right here to make this 0? 1/2. All you have to do is, if you're unsure, just ask yourself the question, what would it take to make that 0? Move the 1 over, divide. X would have to be 1/2, right, for that to happen? So if I let x be 1/2, then I get to rewrite the whole equation. And yes, this is going to be fractions, and it might suck a little bit, but every x gets replaced with 1/2. So 1/2 squared, 1/4 you added, plus what's 2 times 1/2? 1, plus 1 again. So that's your left side. The right side, what's going to happen to this? 0, right? This is going to be 0, kills everything else. This is going to be 0, kills that off. So the only thing left is this, which is what we wanted. So b times a half, and then a half plus 2. That's what we have to do, right? And we're going to use fractions. We're never going to go to a decimal here, ever, in the entire problem. So this is 2, right? 2 plus a quarter. 2 plus a fourth. 9 quarters, 9 fourths. So 9 fourths equals, this is 2 plus a half. 5 halves, 5 over 2. You're getting common denominators here, right? 1, and then you multiply top and bottom by 2, and that's a 4 over 2, and then you put it together, you have 5 over 2. But then times a half, so I'll put that b times a half times 5 over 2. So this is 5 fourths, isn't it?
Yep.
Okay, so 9 fourths equals b, yeah, I should put 5 fourths in front. 9 fourths equals 5 fourths b. And then you either divide by 5 fourths or multiply both sides by the reciprocal. So I'm going to multiply both sides by 4 fifths. Multiply that times 4 over 5, that times 4 over 5, and you should get what? Multiply this side by 4 over 5. Multiply this side by 4 over 5. The 4's cancel, 5's cancel, you get b. b is 9 fifths. b is 9 fifths. Okay. This is the short method. All right. Now I'm trying to get c now. Let x be -2. You're trying to leave this one alone, but kill these two off. So if I let x be -2, it's going to get that one and that one to 0. And you rewrite the entire thing. So what would happen if you do here -2 squared, right? -2 squared, 4, plus 2 times -2, that's going to be -4. So those two are going to kill each other off. And then plus 1 equals, the first two guys are gone, right? The A and the B guys are gone. You just have the C. It's going to be C times -2 times 2 times -2 minus 1. Okay, that's a lot of parentheses, but C times X times 2 times X minus 1. -4 minus 1, -5 times -2, 10. This left side is 1, and this is 10C. So C is 1/10. All right, we got them. We found A, B, and C. So I left this up here. I kind of erased it, but this is how we had it set up, right? It was A over that, B over that, C over that, right? So I would replace my A with what? I'm going to write the final answer up here. Oh, you know what? And I do not want to erase that. I want to leave that. I'll just write my final answer right here. So the way I'd do this is I would put A, -1/2 up here, B, which is 9 fifths, and C, which is 1/10, and I put them like that. And I know that looks weird to have a fraction in a fraction like that, but in calculus, it doesn't matter because what we wind up doing is taking that constant and pulling it out to the front and making this really like 1/10 times 1 over x plus 2, right? That's the same as this. And this becomes something we kind of ignore. I mean, we'll deal with it, but it's not important for the calculus part. Okay? All right, that was the short way. Ready for the long way? Okay, what I would like for you to do, I'm going to give you a few minutes right now. This is not a quiz or anything like that. But what I'd like for you to do is I'd like for you to take this expression right here, and I'd like you to multiply everything out on that side. And then see if
I wish I could kill him in a second.
Like, did you have to do the parentheses first and then have to put in?
All right, anybody have?
Got it. You ready?
I'm ready.
2x squared alpha plus 3x alpha.
Hold on, slow down. 2x squared a, gotcha,
Plus 3xa minus 2a plus x squared bravo minus 2x bravo plus 2x squared Charlie minus x.
agree?
Yeah.
Okay,
And your others feel like the A somewhere, like the 11s.
Yeah, because what I did is I rearranged them.
yeah, but, okay, this first multiplication through, this okay?
Yeah.
Did you have a question? Oh, you're just fixing your hair, okay. All right, in terms of how you write this, this is all correct, like 2x squared a, it's all multiplication. I prefer to write it this way. If it's a number, I write the number, 2. Then I go with the next number, which would be a, x squared, plus 3ax minus 2a, plus b, because b is a constant, squared x, minus 2bx, plus 2cx squared minus cx. That's just, I mean, it's the same thing, but it might help in what we're about to do, which is collect all like terms together. And what are the like terms? We got x squareds, we got x's, and we've got things that don't have any x's, right? Okay, so let's write this down. We have x squared plus 2x plus 1. Also notice that I've been bringing this left side down the whole time. Okay, 2ax squared, and then my next x squared is a bx squared, and then my next x squared is a plus 2cx squared. So I've taken care of all the x squareds. I like to kind of cross them out as I go to make sure I've got them accounted for. Now let me get my x terms. Plus 3ax, got that one, minus 2bx, and then minus cx. And I still have minus 2a, don't I? All right, I think I can do one more step before I start coming up with my equations. Guess I'll erase this now. I'm going to take a look at all my x squared terms, all my x terms, and then my stuff without anything, without any x's, and I'm going to factor out. So my left side is still x squared plus 2x plus 1. The right side, when I pull out x squared, I'm left with 2a plus b plus 2c. 2a plus b plus 2c. That's in front of x squared. Do you all agree that that's just me pulling the x squared out of those first three? Okay, and then the second part, I'm going to put plus parentheses 3a minus 2b minus c, close parentheses, x. And then finally, what? Minus 2a. And now I get to play a little matching game. I need to match the left side to the right side. And when I say match, I mean coefficients. I want to match the coefficient of x squared, this coefficient that's in front of x, and then the number by itself. I want to match those with these three respectively. So that means that the number in front of x squared, this right here, has to be equal to what? 1. The number in front of this has to be equal to 2. And then this by itself has to be equal to 1. And there I have 3 equations and 3 unknowns. So let's write down the equations. And whenever we write down systems of equations, we want to make sure that we line up our variables correctly. So like I'm going to write 2a plus b plus 2c equals 1. And then 3a minus 2b minus c equals what? 2. And then finally, negative 2a equals 1. Does everyone see where those three come from? All right. Well, how do you solve a system of 3 equations and 3 unknowns? Do you remember doing that in college algebra?
Yes.
Yeah. You can do matrices. Yeah.
Or you could also just do elimination.
You can do elimination. We actually know what A is, don't we?
There's another system.
A is negative 1/2. Is that what we had earlier? Was A negative 1/2?
Yes, it was.
It was, right? So it matches up. Boy, you have all sorts of options on how to do this. Let's just a quick show of hands. How many of you solved systems like this in college algebra? Yes? Okay.
I think I did, but I took this college algebra over a year ago.
Yeah, but looks like something you've done before.
It was in the curriculum.
Okay, it is. So in a Cal 2 class, we don't spend any time at all solving systems of equations. We just, at this point, in my Cal 2 class, we just turn to technology at this point. We use our calculators, and I teach my students how to use their calculators to solve matrices, or to solve systems of equations. Because this is tedious. I mean, this one's not so bad, but this part of a problem could take you, 30 minutes to solve this system by hand. So it's easier if we learn how to do it on our calculators. So let's just see a show of hands. How many of you have a Texas Instruments calculator? How many of you do not have a Texas Instruments calculator? Do not. Okay. All right. Are you intending on getting one at some point? Yes?
He said he'd give it to me, and he never gave it to me.
Yeah, so it's not a requirement, but I suggest that anyone who's got, a STEM major that knows you're going to do more math, at some point you should probably get one just so you can do some of these things without having to do them by hand. Okay, let's do this. Next class, if you have your Texas Instrument calculator, bring one, okay? And I'll bring a few extras, and that way everyone in here can learn how to do it on a Texas Instrument calculator, right? But I'll teach you all next class. We know that the solutions to this are going to match what we got with the short method, right?
Yeah.
Okay. So that would be the remaining step, solve that system of equations. All right, I think we need to change it up a little bit. What do you think? Yeah, if you knew what A is, which we do, we could then put A here, and then move it to the other side, and then you have 2 equations, 2 unknowns, and you could do elimination. But then you're going to get fractions. That's why I'm not touching it. I don't want to mess with it. Okay. I think I will borrow your book real quick now. Let me just see it right here.
You're factoring
I got my fancy little
Ace is being really
now.
slow.
Serious.
Really
No?
Yeah, it is. It's this much, and I'm gonna need it.
Probably people trying to sign in.
That's